Euclid is certainly at it again. We're going to cover Proposition 20, and you'll see what he's got in mind. Alright, let's start with this. You have a triangle ABC. And what he says is that if you add the length, now these are lengths of sides, okay? If you add the length of BA and AC together, you're going to get a length that is greater than BC. If you add the length of AB and BC together, you're going to get a length greater than AC, and so on and so forth. So how do we achieve all this? Well, first of all, we're going to draw an equilateral triangle, and we're going to use centermost part A, outermost part C, strike an arc. We're going to use centermost part C, outermost part A, we're going to strike yet another arc. And then we're going to make our equilateral triangle, one side going up here, the other side going over here. And then we're going to use centermost part C, outermost part A, we're going to strike yet another arc, and it's going to land on this point right here. Then we're going to use this point as a center, this point as an outermost edge, strike another arc, and then we'll have a length from A to whatever point that is right over here. Then we're going to strike one more arc, center A, outermost right here, strike another arc, and we end up with point D. And that's propositions 1, 2, and 1, 3 in action. Alright. When we do this, we're going to form an isosceles triangle. Now we have triangle DAC and it's isosceles. And since it's isosceles, the angle ACD is equal in size to ADC. Now why do we care about any of that? Well, first of all, it's wintertime and I'm itching and my clothes are itchy because it's wintertime and my skin is dry, so hang on. Anyway, why is all this important? Well, if you'll notice, angle BCD is greater in size than ACD. And since ADC is the same size as ACD, then we can say that the size of BCD is greater than the size of ADC. Now this becomes important in just a moment. Alright. Now, we can also say, because we're now extending A down to B like this, alright, that the angle BDC is smaller than BCD. Alright, and because of all of this, by Proposition 19, you remember 119? Alright, then the length of DB is greater in size than BC. Now you'll notice that DB comprised of DA plus AB. But have you also noticed that you could add AB and AC together and get the same length as AB plus BD? Because remember, DB plus DA plus AB added together make up DB. And since DA is equal in length to AC, then if you add AC and AB together, you're going to get the same length of BD. So therefore, the sum of the length of BA and AC is greater than BC. Thus the proposition is proved. And you can do this for the remaining two sides. I'm not going to do it, just a waste of time for me. But if you want to go ahead, go for it. I will tell you more in a future video, so stay tuned.